Normal distribution, also known as a bell curve, is a normal set of data. Now, what makes the data normal is its distribution. About 68% of the data lies within one standard deviation of the mean. 95.4% of the data lies within two standard deviations of the mean. 99.6% of the data lies within three standard deviations of the mean, and the rest lies within four. An example of a set of data that is normally distributed is IQ scores. For example, 68% of all IQ scores lie within 85 and 115, or one standard deviation of the mean. The z-score is the number of standard deviations from the mean. A z-score is useful for when you are looking at a piece of data that is not an even amount of standard deviations away from the mean. Say we have a random sample of 1,000 numbers and we wanted to make it normal. How would we do that? Well, we would use the central limit theorem, of course. Basically, the idea behind the central limit theorem is that sampling a distribution of the mean of any independent variable will be nearly normal. In understandable terms, this means that in order to make the data normal, or at least normal-ish, we will take the average of x amount of random numbers and plot the average out in a graph. The average out data will become significantly more normal than if we had graphed it without averaging. For example, if we were given 9 snippets of paper numbered 1 through 9 and we were tasked to graph out the numbers, the graph would come out as a flat line. However, if we were to put those same 9 numbers in a hat and take 3 out at random and average their numbers out, we would find that the data is shaped significantly more like a bell curve than before averaging.